are you, my friends? This is Calculus 1 solved question video number 3 in the playlist I have mentioned. You can check the other videos there, please. Zeros of a polynomial function. You can see that in the complete algebra course, lectures 35 and 37. To find the zero of a polynomial function, so we have to find the c values or the x values that will make the function zero. Now the zeros are two types, real zeros and complex zeros. Very important note here, the real zeros are the x-intercept of the graph of the function. So when you find all the zeros, take the real zeros, they will be the x-intercepts of the graph. Now let's see some questions here. Find the zeros of this function, 3x to the power 5 minus 24x cubed plus 48x. What will make this function zero? Find all the values of the x. As we can see, we try by factoring first, if possible here. If possible, sometimes it is not possible. Okay, so we factor it. To find the zeros, we factor it, and we make it equal to 0. So take 3x as a common factor. This is x power 4 minus 8x squared plus 16. This is complete, perfect. See the formula here. A squared minus 2ab plus b squared becomes a minus b squared. And this one, you can factor by difference of two squares. X squared minus y squared will be x plus y, x minus y. So the zeros are 0 here. It will make this one 0 and minus 2 and 2. So there are 3 zeros in this function. Now what will happen if we have more difficult question? Find the zeros of these polynomial functions. X cubed plus 2x squared minus 9x minus 18. This is easy to factor like question number 1. But look at this one here. Very ugly, and you will see many questions in Calculus 1 like that. X cubed plus 7x squared plus 13x plus 7. We cannot factor in the integers. So we have to use P and Q. That is in the complete algebra course, lecture number 37, rational zeros test. I will show you now what to do. So this is easy here to find the zeros. Just factor by grouping, because we have 4 terms. Take x squared out, x plus 2. Take minus 9 out in the common factor, x plus 2. Now x plus 2 is also a common factor, and inside the bracket here we will have x squared minus 9. Also we can use difference between two squares. So there are 3 zeros, minus 2, minus 3, and 3. Now look at the second one. We cannot factor, unfortunately. This is x cubed plus 7x squared plus 13x plus 7. Just remember that if you cannot factor, use rational zeros theorem or rational zeros test, we call it sometimes in the book. P over Q. So P are the factors of the constant here, plus or minus 1, plus or minus 7. Q as the factors of the leading coefficient, plus or minus 1. Divide P over Q, and then you have to try synthetic. So you can try any number there, plus 1, minus 1, plus 7, minus 7. If you check minus 1, you see the remainder is 0. You have to know what is synthetic division. If the remainder is 0, then we can take this number here is a 0 of the function. So we can take now the quotient. This is what's left, because we have 3 zeros there from the cube. We have found one of them, minus 1. So now the quotient will be x squared plus 6x plus 7. If you can factor this, you factor it. But if you cannot factor like this question, you have to use quadratic formula, which is minus b plus or minus square root of b squared minus 4ac divided by 2a. Remember, a is the coefficient of x squared, 1. B is the coefficient of the x, 6. C is the constant, 7. Put the numbers here and simplify the radicals. You get minus 3 plus square root of 2 minus 3 minus square root of 2. This is not easy zeros. They are real zeros because these are real numbers, but not easy. They are irrational. So the zeros for this function, minus 1, minus 3, plus or minus square root of 2. 3 zeros are there. Now, very important remark here. If you have a function here and you are trying zeros, if 0 is found, like -1 here is a 0 because the remainder is 0, try it again. Maybe it is a repeated 0. You try it again, -1, same number on this quotient here. If the remainder is 0 again, that means this 0 is repeated. So instead of x plus 1, we have x plus 1 squared because -1 is a 0. -1 is a 0 repeated. So we have power 2 here. Then the last one will be 2x minus 5. For questions or more questions on finding the zeros, you can see either the complete algebra course, 35, 37 lectures. And for more questions in Calculus 1, the whole course, you can see Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.